friends, we'll solve problem on kinematics of rigid body. See what is given in problem. At the instant shown in figure, velocity of slider A is 5 meters per second upwards along its path. Find velocity of slider B and velocity of end C of the rod. Length of bar AB is given as what? 5 meters, and length BC is equal to 2 meters. Now see what is given in figure. Now there are two sliders. One is slider A, other one is slider B. Slider A has to slide along this path where this angle is given as 45 degrees with horizontal, and slider B has to slide in horizontal direction where inclination of this bar with horizontal is given as 30 degree. What is given in problem? Linear velocity of point A, velocity of slider A is in upward direction along its path, and magnitude is what? 5 meters per second. That means if I'll represent this one as direction of velocity of point A, end A of rod, this is 5 meters per second. Now if end A slides along its path in upward direction, end B or this point B which is on slider has to slide in horizontal direction. If A moves in upward direction, B will slide in leftward direction. Say this is direction of VB. As you know, linear velocities of 2 points, magnitude and directions, you have to find out where direction of V is known, direction of VB is known, magnitude of V is known. Whenever you know direction of linear velocities of any 2 points, first we will represent ICR. How will represent ICR? We will draw perpendiculars to linear velocities. Now if we draw perpendicular to VB, so VB is horizontal, therefore perpendicular to VB will get vertical line. We'll draw here, say this one is perpendicular to VB. What will get here? A vertical line. Then perpendicular to VA, VA moves or slider A slides along this path which is inclined at 45 degree. From this one, if we draw a line which is perpendicular to VA, you will get point of intersection here. This point is I. This is instantaneous center of rotation, where this line is perpendicular to VA, this line is perpendicular to VB. Now from this one, length AB is given in problem. This one is 5 meters. Using this length and these inclinations, we'll try to find out length I and IB. As this angle is 30 degree, what about inclination of this bar with vertical? It is 90 minus 30, comes out to be 60 degree. And as this line is inclined at 45 and IA is perpendicular to it, that means inclination of IA with horizontal as well as with vertical is again 45 degree. That means this angle is 45 degree. Now if you want to find out this angle, you know addition of all three angles in a triangle are 180 degree. Therefore 180 minus, if we add this one, comes out to be 105. That means this angle what we will get here is what? 75 degree. From triangle IAB, easily I and IB is possible applying sine rule. Next part, what you know, BC length is given as a 2 meter. Now problem is of direction of velocity of point C. Linear velocity of any point on a rigid body is always perpendicular to radius of rotation. How will represent our radius of rotation? Point C will join to point I. That means IC becomes radius of rotation. That means if I'll join point I to point C, I to point C, what will get here? This line represents radius of rotation, IC. Now from VA and VB, we'll decide what is the direction of omega about point I. Say IABI, this triangular plate rotates about I, VA upward, VB leftward. That means this has to rotate in what direction? in clockwise direction. This is omega of bar, you can say ABC. Therefore, as omega is anti-clockwise, velocity of point C, if I'll represent here, is perpendicular to VC, will get in downward direction. This one is VC. Now if we try for inclination of VC, if I'll represent inclination of this VC with horizontal, say this angle is alpha. Any line is inclined at an angle of say alpha with horizontal. If we draw perpendicular to it with vertical, angle remains same. That means angle alpha will find out from triangle IBC. Length IC will find out from triangle IBC. First, IA and IB from triangle IAB, applying sine rule. Next, in triangle IBC, IC is possible, as you know BC and IB length. That means applying cosine rule will find out IC. That means you must know this angle between these two lines, where this angle is equal to, this angle is 90, and next inclination of bar with horizontal is 30. That means this angle is 120 degrees. So using this triangle IBC, applying cosine rule, IC is possible. Applying sine rule, will find out angle alpha. That means taking this figure as a reference, now we'll find out one by one IA, IB and IC. First one, applying sine and cosine rule. First we'll start from where? So from triangle IAB. In triangle IAB, applying sine rule, we'll find out these two lengths I and IB. To find out length I and IB, any length if we take say IA divided by sine of opposite angle equal to IB upon sine of opposite angle equal to AB upon sine of opposite angle. You know length AB is given as 5 meters. Now IA upon what? Just here again same figure, IA upon sine of 60 equal to IB upon sine of 75 equal to AB upon sine of 45 degree. That means if we'll add here angles, IA upon what angle will get here? Angle is here 60 degree. IB upon sine of opposite angle is 75 and AB upon sine of opposite angle is 45 degree. Using calculator we'll find out these values. So IA, if we'll find out here, IA comes out to be 6.124 meters. Next IB, if we'll find out, so IB equal to this 5 into sine of 75 divided by sine of 45 comes out to be 6.83 meters. Once we'll get IA and IB, next part is length IC. This one is possible from triangle. In triangle IBC, will apply here cosine rule. Applying cosine rule, what will get here? Length IC equal to. Again we'll see main figure how we'll get sine rule, cosine rule here first. IC length you have to find out. In triangle IBC, length BC is 2 meter, length IB is known. Therefore IC how will write? IC equal to square root of IB square plus BC square minus 2 times IB into BC into cos of 120 degree. Therefore IC equal to square root of IB square plus BC square minus 2 times IB into BC into cos of 120 degree. Length IB you have calculated just now. It is equal to 6.83 meters. That means this is 6.83 square. BC length is given. It is 2, so 2 square minus 2 times. IB is 6.83. BC is 2 and angle what is known is 120 degree. Using calculator you will find out this length IC comes out to be 8.019 meters. Now inclination alpha you have to find out. To find out angle alpha in triangle IBC, now you know length IC, you know length IP, and you know length BC. As we know all three length and this angle 120 also known, to find out angle alpha we'll use sine rule. Alpha you have to find out, the opposite length is BC, so BC upon sine alpha equal to IC upon sine of 120. Using this one, unknown term is only alpha, we'll find out angle alpha. In triangle IBC, now we'll use what? Sine rule. Using sine rule, we're interested in angle alpha, therefore BC length upon sine of angle alpha, where length BC is at 2 meter, equal to one more angle is known which is opposite to length IC, therefore IC upon sine of 120 degrees, where length IC you know 8.019. Therefore using calculator you will find out angle alpha comes out to be 12.47 degrees. Now you know all lengths and angles are ready, therefore simply applying equation V equal to R omega, easily will get what? All linear velocities as well as angular velocity of the points on rigid body. What is given in problem is linear velocity of point A, therefore we'll write first equation of VA. VA equal to distance of point A from center of rotation into omega of this bar AB, where VA is equal to what? 5. IA you have calculated as 6.124 into omega AB. Therefore, omega of this bar is equal to 0.816 radians per second. Direction you have represented figure, direction is what? Clockwise. Once we will get omega, next VB is possible because VB is equal to IB, it's a distance from center of rotation into omega AB. IB length you have calculated and IB is 6.89 meters. Omega is 0.816 radians per second. Therefore, VB linear velocity comes out to be 5.57 meters per second, and that is in horizontal direction leftward. Similarly, VC if we'll find out, VC equal to, it's a distance from center of rotation means IC into omega AB. IC length you have calculated, that is 8.019 will substitute here. Omega AB is 0.816 radians per second. Therefore, this VC comes out to be 6.543 meters per second. But this is not in horizontal direction, this is inclined to horizontal at some angle here, and this angle you have calculated angle alpha as 12.47 degrees. That means finally your answers are this omega AB, which one is clockwise. Then what was asked in problem, linear velocity of slider B, this one is the next answer, and linear velocity of point C, which is inclined at an angle of 12.47 degrees with horizontal. Thank you.